So, good afternoon, guys. Welcome to NEET World Institute in NEET World YouTube channel. So, in this class, we are going to concentrate on this very short answer questions in 11th IPE class. Okay? Yes. So, today's topic is. So, in last class, yes, we have completed about this mechanical properties of fluids and system of particles, right? And in today's class, we will start with yes. Thermal properties of matter. I guess it's clear now. Now, fine. So the first question which we are going to see is distinguish between heat and temperature. Yes. So like when we come into this EAP set, JEE mains, NEET, whatever the topic, like in thermal properties of matter, we will discuss starting point what is the heat and what is temperature. Okay, if you know the basic difference, then we can easily understand the other things, right? No, easily understand the other things. Got it? So wait a minute, or let me arrange the camera point. I guess it's clear now. Got it? Okay, fine. So, okay. So the first one. Heat and temperature, the thing I need to discuss it right now. So heat is nothing but it's a form of energy, whereas temperature, it is like we are measuring it, either it's hot or cold, right? Heat is a form of energy, and the second point is heat is a source, and third one is unit of heat energy is joules. So energy usually will take it in terms of joules, right? So heat energy, so it is also a joule. Temperature is a degree of hotness or coldness of a body, and temperature is effect. It's an effect. How it affect, like when we can see that either it's hot or it's cold, right? No, and unit of temperature is a Kelvin. We are talking about the SI units of everything. Got it? So heat is a form of energy source, and then its SI unit is joules, and then temperature is a degree of hotness or coldness of a body, and temperature is the effect, and then the unit is Kelvin. Got it? And second question, the application point of view. So why gaps are left between the rails on a railway track? And the similar thing also, like you would have noticed a connectivity. So in that also, like if you see, like if you have noticed the thing, like in between the roads, the gaps will be there. Like the gaps like made up of the metal, right? No. So a gap should be left between these two successive rails to allow a linear expansion. So linear expansion in the sense like when summer is there. So in that time what happens? Obviously the metal parts will get expands, right? So a gap should be left between two successive rails to allow for linear expansion of rails in summer. Then what about winter, sir? So winter, what happens? In summer it expands, right? What happens in winter? It contracts, right? No. So whatever the thing expands in summer, the same thing will be contracted in the winter point. So usually we'll keep it, but for summer and winter it will adjust, like adopt to it. Okay. Third question, if you see, the ventilators are provided in room just below the roof. Why? Why? What is the reason why we are taking the ventilator like just below the roof? Just below the roof. Because the ventilator are placed below the roof to allow the hot air to escape through the ventilators, and fresh air enters the room through the doors and windows by the convection. Okay, convection. So here what happens? The high dense and low dense we are talking wide. So here the high dense particle will be down and low dense particle will be high, or low dense will be down or high dense will be high. Remember that, okay? So when we are talking about low dense and high dense, the particles, yes. So low dense particle will be high, high dense will be low. Okay. So what happens? It goes out, and the cold will come in through the doors. Okay. So that's why we are keeping in the roof, under the roof, like just below the roof. Okay. So next one. The roofs of a building are often painted during summer. Why? So hence it absorbs very less heat received from sun, hence the roof of a building is painted white during the sun. Okay, painted white. Why painted white? when you talk about the radiation attraction, no, like when we talk about some, yeah, sometimes like our parents used to tell that we should not wear black, yes, no, so it's not a spiritual thing, like it's a science behind that, it's science. So when we talk, wear black, no, like the absorption of the heat will be more, okay, that's why we are not wearing black. So they used to tell you wear white, wear this light colors, okay, so that's the thing. So when we are wearing the thing, no, like because of the brush, okay, so the radiation, like the absorption of heat will be more in black, okay, that's the main reason. So hence roof of a building is painted white during the summer, okay, got the points, right? So you can take a note of these questions and then we can go for the next part of the question, right? Yeah, please copy down properly, okay? This is the first question. Yeah, you can take a first question and then you can go for the second and third, everything, okay? So, like I need to introduce once again the thing. So, in our NEET World Institute, we have designed a app which is called the MedWorld app. So, what you want to do is just to download the MedWorld app, okay? So, give a, like you can sign up and give a hi message in the app, okay, in the chat box. So what you will do is, like, our team will be contacted with you and whatever the materials are here, either it is IP 11th or IP 12th for maths 1A, 1B, 2A, 2B, or else physics, chemistry, botany, zoology, whatever it is. So they will give a soft copy material through the chat box, okay? So you can access that material, it's a free of cost, okay? So no need to pay anything, even a single penny you don't need to pay, okay? So it's a free of cost, you can utilize it well and you can write your exam well. So you can score 60 out of 60 by using this material, okay? Yeah. Done. Second question and the third and fourth question you can take a note of this and we can go for the next. Done. So can we go for the next question? Fifth question. Yeah. Still fifth is there, sixth is there, and 7, 8. Yeah. Wait a minute. Yeah. 10, 11. It's going. Okay. Yeah. So up to 15 questions. We have completed 4 questions, right? So we'll go for the next questions. Yeah. So the next question is, what is a greenhouse effect and explain global warming? So yes. Wait a minute. Wait. 1 minute. Yes. So greenhouse effect. So the net result of eating up of Earth's wait. Yeah. Earth and atmosphere due to absorption and the reflecting back of thermal radiation. So the net result, okay, we are talking about the result of Earth's surface and atmosphere due to the absorption and reflecting back of the thermal expansion of Earth by the greenhouse effect gases like CO2, CH4 and N2O. okay, is called as greenhouse effect. And what is the meaning of global warming? Yes, so the longer wavelength radiation received from the sun is absorbed by the earth's surface. Okay, first point. When we talk about the second point, no, this heats up, like when the radiation like receives the earth's surface, no, like received from the earth's surface, like it gets heated up, thereby increasing in the intensity of the radiation. Got it? So this global warming may cause a problem for human life, plants, animal, like whatever the things are present in the earth. So polar ice caps are melting faster. So this is the thing happened by the global warming when this greenhouse effect or everything happens. Got it? Okay. So the next one is state Newton's law of cooling. So the rate of temperature, okay, the rate of temperature of a body is proportional to the difference between the mean temperature. The rate of temperature of a body, like heat, okay, is proportional to the difference between the mean temperature of a body and the temperature of a surrounding. So formula is dq by dt directly proportional to T minus Ts, like temperature minus the surrounding temperature. Okay, so state the condition under which Newton's law of cooling is applicable. Now we have seen what is the meaning of Newton's law of cooling. Now where these conditions are applicable in day-to-day life, in the real life. Yes, so Newton's law of cooling is applicable when the heat loss by conduction is negligible. Heat loss of conduction is negligible and heat loss by the body is mainly by the convection. Okay, and second one is the hot body is cooled in uniformly streamlined flow of air or forced convection. Then the temperature of every part of a body is same. This is the conditions for the Newton's law of cooling. So one is heat lost by the conduction is negligible and loss of heat lost by the body is mainly by the convection. Okay, hot body is cooled uniformly streamlined flow, and if you see one temperature of every part of a body is same. Okay, so what is specific gas constant, and it is same for the all gases. That's the equation. So we'll talk about what is specific gas constant. So for 1 gm of gas, like 1 gram of gas, PV by T is equals to R. Okay, PV is equals to nRT, we are talking, right? So PV by T is equals to R, where for m grams of masses, PV by T is equals to mR. Here, what is R? It's a specific gas constant, which depends on the nature of gas, and amount of the gas. So the second point, the specific gas constant is different for different gases. Here itself we can understand that it depends on the nature of the gas, right? It depends on the nature of the gas. So obviously when we talk about is it different for different gases? Yes, it is different for different gases, right? So the ninth question, what are the units and dimensions of specific gas constant? So joules per kg Kelvin is the unit, and m0 L power 2 T power minus 1 K power minus 1 is the dimension. You remember that m0 L square T power minus 2 K power minus 1 and joules per kg Kelvin. Got it? Yeah. Okay. So can a substance contract on metric and give example? Can a substance contract
like S block?
Sir, you have told that when a substance is heated, it expands. But when a substance is heated, it is contracting. So what is that substance? Yes. So if you see lead, cast iron, pure water, rubber, etc. Yes, we have seen the rubber, na? Yes, a substance. When we heat up, it contracts. So when heated from 0 degree to 0 degree Celsius to 4 degree Celsius, contract on heating. So example like this is the example, lead, cast iron, pure water, rubber. Okay, are the examples. Okay. So you can mention the example like this, and you can mention the example again. So because they have asked the two questions, so you can no need, like you can write a single line, it's enough. Okay. So next one, why utensils are coated black? Why the bottom of the utensils is made of copper? Why it is? So black surface is a good absorber. I have told you, right? So we used to wear black, and our parents, our
like sodium, potassium. Whenever these first aid.
So black surface is good absorber, like it absorbs more heat, okay, and a good emitter too. So So hence utensils are coated black. Copper is good conductor of heat now. Okay. Hence copper is used at the bottom of the cooking utensils. This is the reason. It absorbs heat and it's
They are saying when it is burning.
so next one is take Wien's law displacement. I mean Wien's displacement law. So Wien's displacement law tells that okay, wavelength corresponding to maximum energy emitted by a black body is inversely proportional. Wavelength lambda corresponding to a maximum energy emitted by the black body is inversely proportional to absolute temperature. Yes, no? So lambda is that inversely proportional to temperature. When I take the T other side, lambda into T will be constant. Okay, and the value of the black body like a Wien's displacement law is 2.9 into 10 power minus 3 meter Kelvin. Yeah, what are the lower and upper fixed point that of Celsius and Fahrenheit scale? So this is the easiest thing. Lower fixed point of Celsius is 0, upper fixed point is 100, and lower fixed point of Fahrenheit is 32, and upper fixed point is 212. Right? And what is this scale difference? It is 100, it is 180. Okay, scale difference in the sense upper
It will
is lower.
2 only.
So the next question: why do liquids have no linear expansion? No linear, and it has aerial expansion. Any liquid requires a container for its existence. So liquid do not have a specific size. So hence the liquid do not have a linear expansion and the aerial expansion. Got it? So what is the latent heat of vaporization? Yeah. See here the liquid itself, like when utensils itself take the shape of the liquid. Right, that's why it doesn't have the linear and the aerial expansion. Okay, so what is latent heat of vaporization? So latent heat of vaporization means nothing but the quantity of heat required to change unit mass of liquid.
Okay, so therefore there is no time gap.
Called as latent heat of vaporization. And what is the value of that? 540 calories per gram. Okay, so this is about the thermal properties of matters. BSAQs, that is two very short answer questions. This 2 mark questions. Okay, so if you are good in this 15 question in this chapter, it is you can get out in this chapter. Okay, so similarly, whatever chapters we have discussed, so please be confident enough to answer those questions. Okay, so thank you guys. With this, I'll conclude this thermal properties of matter class.
Between
And we'll be the next class with kinetic theory. I mean, yes, no, like KTG, kinetic theory of gases. Okay, thank you guys.